Okay, so we've been talking about these trig functions, and we've been working on doing them in the calculator. So I want to start off with a little bit of review today. I'll just be writing these down for you. You can figure them out as you go. Yes, you might notice a pattern developing here. I'm being really creative with my numbers. There, I'll pause this.
Uh-oh.
Okay, so sine of 30.
That'd be point.
Sine of 30 was 0.5, good. Cosine of 30.
0.8660.
0.8660.
Do you really need to add the zeros on?
No.
Get to your,
Oh, I just try to go to 4 decimal places. Oh.
0.5773.
0.5773 is the tangent. So, excuse me. Up to that point, how many people are good? 1.1546.
Take the cosine.
The way you do this one is you do cosine 30. That's outside the parentheses on this one. It's when you go the other direction that the x negative 1 is inside the parentheses. So for cosecant, you guys need to redo cosecant, cotangent quick? Yep. So cosecant.
Always on the outside of the parentheses?
Yep, so it'd be like this, right? So this would be 2.
Yep, that's what I got.
And then this would be tangent of 30. X negative 1. 1.7321, isn't it?
Yeah.
Everybody's really comfortable with those? Make sure you have that process in your notes. Next. Bless you. Find A for each of these. Or B, whichever letter I use. So we're going to start off with these 3. Oh, what's this going to come out to be? 8.
0, 1, 4, 6.
No. 56.84.
56.84? Okay, so this one you're doing inverse. So this one you're going to do second sine 0.8371. 56.84.
You have to close parentheses?
You should. I mean, you don't have to on this one, but you should just get in the habit. There you go, 56.84. So then B,
21 and 18.
0.18. Notice, well, we're going to point this out as part of our lesson, but notice here, this is almost one that's a big angle. This is almost one that's a small angle. We're going to look at that here in a couple minutes. Tangent D comes out to be
67.64.
67.64. So 6.3. Okay, we'll go 6.3. Unless you two want to go outside and fight it out to see whether it's 3 or 4. I just want to take bets.
Between me and John? Who are you fighting? Who do you need to win?
So anyway, what's F?
Oh, F would be 16.96.
Do you guys concur? G.
74.91.
You guys concur? And H?
32.3.
Concur?
Good at pushing buttons on a calculator.
Yes, you are. You're the best button pusher we got.
You know, with me, the challenge is going to be, I know how to work my calculator now. I know how to get the answer.
Yep.
But how?
Well, give me about 10 minutes here.
All right.
Back to this unit circle thing. Okay, we've talked about this a few times. There are some things on this circle that we need to point out.
0, 90, 70.
Here's the 0 degrees.
Yep.
Here's the 90 degrees up here. 180, 270. There are some things about each of those that we can observe. First of all, the radius of this circle is 1. So let's say we have an angle here that's really close to 0 degrees, like 1 degree or whatever. The sine is this distance here. What can we say about the sine of that angle? It's almost 0. It's really, really tiny. Small angles have small sines. The cosine, however, is this distance here. What can we say about that? It's almost 1. At 0 degrees, the cosine is 1 and the sine is 0. But as that angle gets larger, like somewhere in here, now the sine has gotten larger and the cosine has gotten smaller. In fact, once we get to this point here, let's say we're almost to 90 degrees. Now, the sine, of course, is that distance. Now what can we say about the sine? Well, it's not huge, but it's almost 1. Right? It can never be larger than 1 because it's always inside the circle. But it's almost 1. The cosine, however, down here is almost 0. Most of the... What's that?
As the sine gets bigger, the cosine gets smaller.
Yes.
They're complements of each other.
Exactly. They're complements of each other. The numbers themselves aren't complements, but they're of the complementary angles.
Yeah.
This here, most of the angles you're going to work with are between 0 and 90. At the very most, you go up from 0 to 180. You get past that, it's not a big deal. This is the biggest thing you need to know right here. That if you have a really small angle, it's going to have a really small sine. Cosine is going to be almost 1. If you get a bigger angle, almost 90 degrees, the sine is almost 1 and the cosine is really small. As long as you keep that in mind, it'll save you a lot of stupid mistakes on your calculator. Now as we go past 90 degrees, like right here, just past 90 degrees, the cosine, or not the cosine, the sine is still that height, right here. It is still almost 1. It's still pretty big, close to 1. The cosine is still pretty small, but what's different about the cosine here than it was over here? It's now negative. It's on the negative side. So between 90 degrees and 180 degrees, the sine is still positive because it's still up above the horizontal axis. But the cosine now becomes negative. Just like as we keep going down to here, the sine is now almost 0. It's very little, right? And the cosine is almost a negative 1. Go out to here. Keep going. Well, down here, of course, now both the sine and the cosine are negative. Because here's the sine right there. That's below the horizontal axis. That's negative. Here's the cosine. That's still on the negative side. So both are negative down here. Over here, of course, is the sine negative or positive? Sine is negative. However, the cosine is now, once again, positive because we're on this side. Exactly. It is the XY coordinate system. It's just with a circle superimposed around the origin. Now, with all that said, there are some relationships that we should talk about. We mentioned this on the first day that we looked at the unit circle. Pretend that's round and that goes through the center. Let's say we have this angle here that's 40 degrees, or we have this side here that we're looking at that's at about that 40 degree location. Do we know for sure that that angle is 40 degrees if it's labeled? Not necessarily. What could it also be? Yeah, it could also have wrapped all the way around. It could be 360 plus 40 degrees. It could be 40 degrees. Or it could be 400 degrees, 360 plus 40. Or it could have wrapped around twice. It could be 720 plus 40. It could be 760 degrees for all we know. You look confused, Jason. Well, it's just, it could be any increment of 360. Or it could have gone backwards. It could be a negative 320 degrees. What we call these angles is something called coterminal. Coterminal means that they end at the same spot on the unit circle. 40 degrees would stop there, negative 320 would stop there, negative 680 would stop there in that same spot. Positive 400, positive 760, positive 1120. All of them end in that same spot. How do we know which angle it is? Well, the answer is we don't freaking care. Because its sine is still there. Its cosine is still there. So we don't care whether that's 40 or 400 or negative 320. It has the same sine and the same cosine. This was a lot more important of a concept 40 years ago when we didn't have the fancy calculators. Back then, when, as David was mentioning the other day, where you had the tables you had to look it up in, those tables did not go from 0 to 2,000 degrees. They went from 0 to 90. And you had to know what one to look up. Not only was 40 and 300, or 40 and 400 and 320 related, but there was a relationship between 40 degrees and this one might call 140 degrees. Why would there be a relationship between these? Well, what's this angle right here? 40 degrees. Why is it 40? It's supplement. That's a straight line. That diameter is obviously a straight line across there. So there's supplements. Well, we'll see there's 40 degrees here and 40 degrees here. What does that tell us about this height right here compared to this height right here? They're the same. What's the sine of 40 degrees? Punch in your calculator.
0.6428.
Perfect. 6428. Well, then punch this one in your calculator. Sine of 140 degrees. Exactly the same thing. Why? Because of the geometry of this unit circle. This height and this height have to be the same. Now, cosine of 40 degrees is 7660. How about over here then, the cosine of 140 degrees? Negative 0.6 or 0.7660. Same number, it's just negative because it's on the other side. Because physically, this length and this length have to be the same because of the geometry of the triangles. This thing right here, the 40 degrees and this other 40 degrees, are what we call reference angles. Both of those angles, the 40 and the 140, have a 40-degree reference angle. What that means is the angle between it and this horizontal diameter. Now remember, we called that the reference diameter, and this is why. Any terminal side of an angle that has the same reference angle with that diameter is going to have related trig functions. These both have a reference angle of 40. Their sines are the same, and their cosines, same number, opposite sign. Are there any other angles on here that would have the same reference angle? Yeah, I could go 40 degrees this way. What would that be? Well, this is 180 plus 40. That would make this 220 degrees, right? Just for fun, on your calculators. Come on. Sine of 220 degrees. Negative 0.6428. Cosine of 220 degrees. Negative 0.7660. Your calculator will confirm that if you punch it in. I don't need to punch it in because I know the relationship. There's one more spot here that has a 40-degree reference angle. If this is 40 degrees, what's this terminal side at? 320. 360 minus 40 is 320 degrees. Without your calculator, can anybody tell me the sine of 320? Negative 0.6428, because this is down below. Can anybody tell me the cosine of 320? Positive or negative? This is positive. It's on the positive side now for the cosine. Other relationships that were big, some of those tables didn't contain the cosine, they just contained the sine. Because we mentioned if this were 20 degrees, its sine is right here, right? Where the cosine came from was the sine of its complement, which was this angle over here. So if I tell you that the sine of 20 degrees is, somebody punch that in for me. 0.3420. Can you find, without your calculator, the cosine of 70 degrees? 0.3420. The sine of an angle has to equal the cosine of its complement, or the other way around. The cosine of an angle has to equal the sine of its complement. If I know that the sine of 30 degrees is 0.5, what's the cosine of 60 degrees? 0.5. In our little formulas, we said the sine of an angle is the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. We said the tangent of an angle was opposite over adjacent. What if we were to take the sine of an angle divided by the cosine of that angle? Well, looking at the terms of the sides, this is opposite over hypotenuse. That's the sine. The cosine is adjacent over hypotenuse. I don't know why I keep writing G's instead of D's today, but
Yeah, I noticed you do that sometimes.
I'm dyslexic, so it happens a lot. Did I ever show you guys that?
Yeah.
I write upside down? For some reason, the last few days, G's and D's have been off for me for some reason. Anyway, if I divide that out, I'm going to take the reciprocal of this one and multiply. What happens? Well, the hypotenuse cancels out. This is opposite over adjacent. Does that look familiar? Tangent of 60 degrees is, if you punch it in, 1.7321, right? Sine of 60 degrees is 0.8660, right? Cosine of 60, 0.5. You guys can punch these in to verify. Now what I want you to try to do is this. On your calculator, we're going to do sine of 60 divided by, and make sure we close the parentheses, cosine of 60. What do you get? Yeah, 1.7321. So now,
Sine of 60 is what that was?
yeah,
You close it?
and close it. Sine of 60 closed divided by cosine of 60. Right here. It equals.
Close it?
Yep. 1.73205. Yep. Which is the exact same thing you get when you do the tangent. So now again, we have the calculator, so we can use the calculators to find the tangent. But if I were to tell you that the sine of x is 0.6, and the cosine of y is 0.8, and x plus y equals 90 degrees. Oops. Not the cosine. I wanted the sine of y here, sorry. The sine of y equals 0.8. So sine of x is 0.6, sine of y is 0.8. X and y equals 90 degrees. What does that tell me about x and y? They're complements, which means the cosine of x is going to be how much? 0.8. It's got to equal the sine of y, because they're complements. What's the tangent of x going to be then? Well, from what we just saw, you can find the tangent as the sine over the cosine. We know this. We were given the sine of x is 0.6. We found the cosine because they're complements to be 0.8. 0.6 over 0.8 is 0.75. The tangent of x would be 0.75. If you want to confirm this, we can use what we learned yesterday. The sine x is 0.6, cosine x is 0.8, tangent x is 0.75. Find x. Well, let's use the inverse sine of 0.6 to find x. 36.87 degrees. If I do the inverse cosine, what should I get? Second cosine, we're going to use 0.8 there. We better get 36.87 degrees. If I use the inverse tangent of 0.75, I better get, who wants to say it?
36.86.
87 degrees. There you go. You gotta have a little more enthusiasm in your voice, though. You're not quite pulling it off. I don't think I'd buy the car from you yet.
Yeah, you would.
Okay, so in your packet, somebody want to double check in their packet, make sure pages 345 and 347 are in there, and I don't have to give you a new packet. I believe they're in your current, they're probably the last pages in your current packet. They're in there? Okay. These pages talk a little bit more about the relation, they require you to know the relationships and stuff like that to figure them out.